Good morning, everyone. My name is Tareef Kawaf, and I'm the president of RStudio. And I like to set context in the beginning. I am not a statistician. I'm not a data scientist. I am not a modeler. I am not an expert in machine learning. So you might be asking yourself, why are you here? And that's a good question to ask in general. So when I first got this invite, I spent a lot of time trying to think about what would be an interesting talk for everyone. And I happened to be listening to a podcast by, that was interviewing a gentleman by the name of Ian McGilchrist. And he wrote a book called The Master and the Emissary. I'll have all these things at the back of the deck. But in his topic, he brought up a point that I thought that really struck with me. And he was sort of talking about the brain and the left brain and the right brain and the differences between those brains and how the left brain is more about focus and detail and the right brain is more about holistic thinking and sort of looking out at a... But he asked this question that stuck with me, which was, why is the brain, which is an organ that exists only to make connections, why is it divided? Right? It's an interesting question. We've had millions of years for the brains to evolve, and we still have two sides. So, how many people, raise your hands if you can see one image. Can anybody see any images up here? One image. Nobody can see any images? Raise your hands. Nobody can see a single image. All right, two people can see an image. How many people can see two images? All right. Great, awesome. So can you see the white base there in the middle? Fantastic. So if we pull up, and this is rendering funny, but you'll see that there are actually two different silhouettes, right? And we're going to use this in the talk to sort of represent left brain and right brain, okay? And so zooming out naturally gave us you get more distance, you get more perspective. You understand that what you're looking at is the space between two heads, right? And so here's a squirrel, right? A squirrel goes hunting for food, climbs trees, goes across the grasses, hides it. When the squirrel is doing all of that, it's very much in its left brain thinking, right? It has a task, it's following up every last detail. But just like the squirrel and us, we also have this way of toggling back. We look at the greater distance to be able to identify threats. So getting the notion of context is really, really important. So what I'm going to try and do today in this talk, and I'll try to slow down since I talk very quickly, is talk about how machine learning and humans and the interaction between the two are going to fit together, right? And so this is a potential thesis that we're going to run with. So how do machines learn? And typically machines learn from many, many examples, right? You feed it a lot of data, and you sort of train it on the data, and you can create then a model from that. And one of the side effects of that is that you end up usually getting a very narrow set of use cases that the machine learning algorithm solves for, right? So if you've built a model that's been trained on a bunch of images, you probably are not going to be able to do that transfer learning to audio, right? And it's usually a little bit of a black box for you. It's really difficult to interpret. That's why people invent tools like Lime, for example, right? So how do humans learn? And we'll start with the most typical humans. We'll start with children. And children usually learn from examples, right? They see how their parents work. They see, you can go and show your child a picture of a dog. Then you can show them a live dog. And you may show them a couple of examples of dogs. And then when they see something that looks like a dog, they're going to say, that's a dog. They don't have to see all the dogs to know that something is a dog, right? And so they can extrapolate. They can guess. All right? How do adults learn? There was a paper that came out, not too long ago, from Stanford that talks about like 3 different ways of learning for adults, right? And behavioral model is the first one. And it says, you know what, for every stimulus, that creates a response of some kind. And that's either reward-based or it could be punishment-based. So I have 2 boys. One is 7, one is 11. We use this all the time, my wife and I, right? If you want to play, you have to finish your homework and play the piano. Oh, you want to go with your friend? You can't go with your friend because you are not good to your brother, right? Those are examples of behavioral models. But there's also the sociocultural model, right? Where we learn from other people, from the culture that we live in, right? We as people that are, these kinds of people do these kinds of things. These are the norms that we define, right? And we, for our children, we'll show them what that looks like. So I try to show them what a good father looks like, what a good mother, what a family looks like, what a culture, you know, what your citizenship looks like, right? So that's a sociocultural model. And then finally, there's the transformative model, right? This is where something happens in your life that is disorienting. It changes how you think about the world, and that gets you to re-examine your assumptions. Those are the key ways that humans learn. And what we're positing here is that machine learning is very much on the behavioral learning side, right? So humans learn in much richer ways. Now, I don't want people to misunderstand me. Machine learning is amazing. The things that you can do now and that have been happening over the last 10 years have been astounding, right? Whether it's self-driving cars or AlphaGo beating the world Go master 3 out of 5 games, or even more impressively for me is the AlphaGo Zero. I don't know how many people are familiar with this, where they just gave it the rules of the game and had it play against each other to sort of generate the models to then be able to compete, and then it beat AlphaGo. Alibaba recently, you know, had a model that sort of comprehends writing and beat Stanford University students, and Google announced with Duplex that it could sort of make reservations essentially and handle and talk as if it's a human being. So it's really, really incredible what's possible. But there are limitations. And so there were a couple of examples that came out not too long ago. One was somebody, you know, Google had built a model about animal species classification, and somebody uploaded a picture of a black person, right? And it got categorized as a gorilla. And so Google had to apologize and take that down. Microsoft created something called Microsoft Tay. It's a conversational bot. It would learn from social media and would adjust on the fly. And it started learning within 24 hours. It started swearing, using racist language, and denying that the Holocaust ever happened, right? And so they had to apologize and take that down. Now, those are not problems. That's a mistake of machine learning, right? This, to me, highlights more of the limitations of a narrow algorithm, right? And it illustrates the importance of what a data scientist is supposed to do when you're using these algorithms, right? So the best ML examples are trained on large data sets, but the reality is most people don't have really big data sets. Most people have small to medium data sets. They have large number of original predictors, multicollinearity, class imbalances, et cetera, right? So Max Kuhn, who is one of the top people in data science, in machine learning in the R community, who works for RStudio, had this to say, and I thought it was important for us to bring that up and just remember as you're sort of looking to apply machine learning and AI to business, for you to be aware of what the strengths and weaknesses are and to understand when you should be using the tool and how. Now, machine learning itself continues to move forward. A few weeks ago, maybe a month ago now, the Google Doodle had the celebrating Bach. Right? And what you could do is you could go ahead and type in, you click on the melody that you wanted, and it would apply this model to be able to harmonize as Bach would have, right? Now that's cool, but what was more interesting for us is this quote from Anna Wang, who's the lead developer of Celebrating Bach. Right? And what she said is, sometimes I want to work on an idea very precisely in all its details, and other times I write down notes just as a placeholder so that I can see the overall shape of the piece, right? And this to me is really all about problem solving, right? On one side, it's the left brain, right? You're working on the details, and on the other side, you're taking a step back and taking a look at the overall shape of what you're doing. Does that make sense? All right, so I mentioned the Master and the Emissary book and the podcast that I listened to, but 4 days ago, I happened to come across a YouTube video by a mathematician by the name of Hannah Fry. And has anybody seen the YouTube video of this? No, doesn't look like it. So I'll have a link to the book at the very end. But so she talked about a group of scientists who decided to grab 19 subjects and teach them to sort of train them to be able to identify cancer from radiology images, right? So 19 subjects, they put up a lot of images for them, taught them how to, told them when they got it right, told them when they got it wrong, and so on and so forth. And eventually they got to a place where you could ask any one of those subjects and say, here's an image, what do you think? And they would get it correct. They give the right answer 85% of the time. All right? Then they figured out if they grabbed 15 of those, the top 15 people, or the 15 subjects, and you gave them the same problem, they would get the accuracy up to 99%. It's pretty amazing for people who don't know anything about radiology, anything about cancer, right? You sat them down, showed them a bunch of images. Now, that would be a fun story in and of itself. What's most amazing is that these were pigeons, right? So this is literally the definition of an ensemble of weak learners, right? They don't know anything about cancer. They don't know anything about radiology, but they get trained on a bunch of images, and then suddenly you can get the accuracy to be ridiculously high, right? And this, to us, is like the future of automated machine learning, right? I know you take a whole bunch of ensemble of models, and you can end up with a much stronger solution than what you could get by itself. And so, and we have some really good partners here in H2O and AgileSoDA who sort of have invested in solving these types of problems for people. So if AutoML is the future, right, what is the role of the human, right? And this was also from the same podcast, and they were talking about the story about like intent versus outcome, right? And apparently there is something called the Transcranial magnetic stimulation. It's something that you can apply to like a side of the brain, and you can sort of essentially turn off that hemisphere, okay? And so they brought a whole bunch of people in, split them up into different groups, applied it, some to the right brain, some to the left brain, and you have about 15 to 20 minutes where that's disabled. And so you can have a conversation with somebody and they will respond from the other hemisphere. So far, so good. And they basically walked them through two different scenarios, and then they asked them a couple of questions. And so I'm going to run you guys through the scenarios. So the scenario is you've got two gentlemen. One is named Myung-bo, and the other one is Ji-sung, right? In the scenario A, they're friends. They get together for a cup of coffee. And Myung-bo puts some sugar for his friend, and his friend drinks it, and he dies. It turns out that sugar was really poison. So that's scenario A. Scenario B, Myung-bo and Ji-sung are rivals. They hate each other. They happen to grab a cup of coffee together. Myung-bo sees this as an opportunity to get rid of Ji-sung, and so he puts a white poison in his coffee. Ji-sung drinks it. Turns out it's sugar. So he lives. And so now they ask the people whose right brain has been turned off. They ask them, which scenario is worse? Okay? And all the people where their right brain was turned off, they said, scenario A is worse. Somebody died. The outcome was death, therefore it is bad. They do the same for the other side, ask the same question, and this time they say, scenario B is worse, because Myung-bo tried to kill him. The fact that he didn't succeed is immaterial. The fact that he tried to kill him, whereas the other one is an accident. Okay? And so why is that? And it turns out it's because the left brain is very much about outcomes, right? And the right brain is very much aware of the context. And this to us is precisely what we're talking about here with machine learning and humans, all right? We, the humans, have to be the context. So what is the role of the human? And we think the role of the human is you have to feed the right data, right? Make sure that the data that you're selecting has signal. Try to interpret the results for validity. Try to make sure that the features that are being selected, and see if there's any bias that's happening here, right? You want to be able to contextualize the results, and to be thinking about whether the results are applicable to the given problem that you're working on, right? So those of you here may like football, right? Korean team, South Korean team is fantastic, did really well in Asia. You think about him as the role of the human is kind of like the midfielder, right? The person in the middle who sort of distributes the ball, figures out who's going to get the ball where, right? But it goes beyond that, right? There are really important questions that come up here, right? Questions around ethics, right? So are you being inclusive? Are you thinking about people who are underrepresented? Are you making sure that the models that you're building are fair, right? Do you have protections for abuse? Are there ways for you to detect if abuse is happening? Can you prevent it? Are you monitoring it? Is a human involved at all? Is there a way for people to escalate these issues? These are all questions that I think are going to become more and more important for us as we leverage these machines to answer a bunch of questions based on the data that we feed it. And then in general, whenever you're building models, whether you're using AutoML or machine learning, you have to be asking yourself, what is the business value of the problem that I'm solving here, right? Are my stakeholders bought in? Do they believe in what we're doing? Is the impact of the problem worth solving for? Don't get too stuck in the technology and the overfitting of the models, right? Figure out how to get into production and figure out how to manage the changes that occur, right? So monitor, make sure that the model continues to give you the kinds of results you expect, and you retrain it on a regular basis. If you fail to do these things, you ultimately are running a risk in terms of what you're deploying. So as I mentioned, I run a company called RStudio, so I thought I'd talk a little bit about R. R is a language, it's an open source implementation of a language that was created in the 70s called S. It was created at AT&T Bell Labs. The folks who created it because they needed to create a language that allowed them to interact with their data and to be able to visualize it and understand it. And so there were a bunch of libraries in Fortran and C, and so they created what they defined as a glue language that sort of was a useful interface language, right? And in this modern world today, you would think about, I don't know if this is easy to see, but it has Spark, TensorFlow, and Keras, right? And you can think of those as the tools, right? And then languages like Python and R as interface languages that allow a human being to interact with those powerful tools. So at RStudio, here's what we believe data science looks like today, right? You import data, you tidy the data, you transform the data, you visualize the data, you model the data, and then you repeat over and over again until you understand something. And once you understand it, you need to share it with other people. And that's what the communication side is. So this is what we believe in. And we are comfortable with the idea that in the future, you may have more of these kinds of models where you just import a whole bunch of data, a whole bunch of machine learning algorithms apply, black box, and then it spits out the answer, right? But even in this world, it's really important, in our opinion, that you have the right brain apply, right? And the right brain here is about thinking about your user, thinking about your biases for gender, neutrality, safety, and the law, right? Are you discriminating against people based on a flaw in your algorithm? So RStudio is a company. Typically, people know us as the company that provides the IDE for R. We probably have the most popular IDE for R. But we do so much more than that. We invest quite a bit in open source packages. So packages around importing data, modeling data, and here I'm going to run you through some of the things that might be interesting to this crowd, right? So we've invested over the last few years in creating bindings from R to TensorFlow, Keras, Spark. We're giving you sort of tools to do TF runs, deployment of the models. Last year, Wes McKinney, who's the guy who created the Pandas package, joined RStudio to work on the Apache Arrow project to create a general purpose runtime that is applicable across all different languages. So you can slice and dice 100 gig data sets on a laptop. We worked with Databricks on MLflow. And so if you're interested in any of this stuff and you want to sort of see what's possible, visit the tensorflow.rstudio.com and take a look at all these various examples that you can have where you can build using the R language, but underneath the hood, it's all translating into TensorFlow, right? TensorFlow is a C++-based library for deep learning. So we also build packages for communicating and so for sharing with other people. So this is a subset of the packages that we maintain. We maintain over 150 packages. The R ecosystem has over 14,000 packages, and so it's a very rich ecosystem. And it is a remarkable tool chain if you're sort of interested in digging into it. Now, we fund all of this with commercial products we build. So we have several products. I'm going to run you through them so you have a sense of them. But those are professional products that are used by over 1,000 organizations today to run R in enterprise deployments, right? And so today I'm going to give you guys a little sneak peek, so don't tweet this to the world. But basically in the next week or two, we are going to be announcing a release of our new product called RStudio Server Pro 1.2. And in this new version, we're going to actually decouple the work that is, so today any of our server products will run the R process on the same machine as that server. And what we're trying to do here is create this abstraction layer that makes it easy for you to connect to things like Kubernetes or Slurm or LSF or your Mesos or whatever your favorite orchestration or job execution engine will be. And so we believe very strongly that the world is moving towards this world of containerization and being able to run workloads in a very elastic way. The next product that we have is RStudio Connect. And we basically created RStudio Connect as a way for you to publish your data products. And so what are data products? Well, data products are basically anything that your data scientist can create. So whether it's a Shiny application, an R Markdown doc, a Jupyter notebook. We announced in January that we now add support for Connect to be able to host and schedule Jupyter notebooks on there. Whether you want to be able to host REST-based APIs, plots, be able to get emails on a scheduled basis. So all of these kinds of use cases are covered underneath RStudio Connect. And most notably, last year we announced the ability for you to serve TensorFlow models from Connect. And so, so whether you've trained your model using Python or whether you've trained your model using R, right, you can sort of deploy it to Connect and know that you can run it sort of at scale. Whether it's behind your firewall in your on-premise solutions or in your AWS or GKE platforms. So, all right. So, and the last product that we introduced last year was the RStudio Package Manager. Again, this is if you're in the R space, you want to be able to manage the versions of packages that you're using, be able to sort of manage the repositories, understand the relationships between packages, understand the system dependencies, and so on and so forth. So, this is what I call the virtuous cycle, right? The open source tools that we create are accessible to everyone. And then the commercial products are what allow us to invest into the open source tools, right? So that's, to us as a company, those are the two missions for us. In terms of the investments that we're making, we are continuing to invest in Kubernetes and Spark, it's modeling at scale. We're also even creating like we're trying to define a grammar of modeling, if you will, that people could apply. On the Python side, we've added the ability for you to publish Jupyter notebooks, but we've also extended the IDE itself. So if Python is your second language and you want to be able to use that, you don't have to necessarily use the RStudio IDE. One of the other things that I'm really excited about is this, the idea of being able to build Shiny applications or R Markdown docs that leverage Python underneath the hood, right? And so we call them reticulated Shiny applications and reticulated R Markdown docs. But basically, if you have people in your organization, and you will invariably have more people that use Python than R in any organization, typically. But if they have built a really cool library that you want to be able to leverage inside of a Shiny application or an R Markdown doc, or you want to be able to schedule it, you can now very easily pull that in and run with it, right? Again, this is R as an interface language, R as a glue language, right? We're investing quite a bit in reproducibility, both in terms of the package manager, but also in terms of open source packages that make it easy for you to track the versions of packages that you're using and be able to recreate that on another environment. This is really important for science in general, but also really important for some of our pharmaceutical company and healthcare providers. And then in general, we are investing quite a bit in just making things easier and better, right? So, and keeping up with the latest and greatest. So TensorFlow 2.0, MLflow, et cetera, right? So, all right, so in conclusion, our position is that we care about both sides. We love code, right? We clearly invest quite a bit in an IDE that makes it easy for you to create code and maintain code and version code and so on and so forth. But we also believe very strongly in people and the importance of people in that pipeline. So, try and close this down. So, you remember that question about why is the human brain in two parts, right? And I think I continue to feel like that is an important thing for us to noodle on and think about. And if you buy into this idea, then you can sort of think about machine learning as the left side of your brain, right? And the human as the right side of the brain, right? As the context piece. If you believe that argument, then you will believe that there will always be a role for humans, right? It may look very different than what our typical view of what a data scientist or data analyst does today, but over time, that will be just another tool in the toolbox. And then R as an interface language, as a way for a human to express their ideas and reflect that and have it connect to a variety of underlying systems, right? And finally, we as an organization contribute quite a bit. We spend most of our time in R, but hopefully you can see from this talk that we invest quite a bit in general tooling that makes open source data science more accessible to people, right? Whether that is TensorFlow, Spark, Keras, the Ursa Labs, the Apache Arrow initiative I was talking about. So at the end of the day, what we believe very strongly in the power of open source and what good that sort of drives in the world. I promised you sort of a snapshot of these. These are the two books. I've read the one on the left, The Master and the Emissary. It's a little bit of a dense read. There's quite a bit of philosophy there, but if you're interested in it, it focuses just on the left brain, right brain conversation. The one on the right, I'm going to read it on the flight back from Seoul this weekend, but the podcast and if you YouTube Hannah Fry, you can sort of watch a 36-minute video, and she has a bunch of really interesting examples about machine learning and the strengths and weaknesses of that model. So with that, I want to thank you for inviting me and for having me here. And I don't know if there's questions and answers. I'm happy to answer questions for a few minutes. So if you don't have time, I'm going to be around all day, and I'm happy to answer questions outside. Thank you very much.